welcome to the lecture number 22. We have been discussing about the transformation of psi dot, theta dot and phi dot to omega 1, omega 2, omega 3. So, we will continue with that, and so I told you that we will do this through this figure also. So, let us say that this is 1/2 of the circle and the other half is lying here. So, if we rotate it, so the rotated circle, if I rotate it by theta, so the rotated circle it will look like this. So, I have rotated this line by theta angle. Okay. So, the rotation, that rotation we have given about this line by theta. Okay. Now, I complete this first the triad. So, this is your E 1, this is E 2 and E 3, okay. And the first rotation if we give about this E 3 by psi. So, psi dot is lying here. So, that does not change anything except that the axis gets rotated. So, here you will have E 1 prime and this gets rotated. So, I show it by dotted line here, and here this solid means this is below this blue line. E 2 prime, then okay, we need to do the correction here. So, we rotate it by this is rotated by psi here. So, this comes here and this goes here in this place, and these two are perpendicular to each other. So, the next line this rotated, this gets rotated from this place to this place. So, we can show this line here itself. So, this is your E 1 prime, E 2 prime goes here, E 2 is here. Okay. Next rotation we are giving by theta here itself. So, E 2 prime will be E 1 double prime will be here, this will come out and it will go on to this circle, because we are rotating here by theta and already we have rotated this plane by theta. So, this I will show by some other color. So, this goes from this place to this place. Okay. So, it has turned up. Okay. So, it has gone up from here to here, this angle is theta. This line is below this blue line, while this red this pink line is in this plane itself. Okay. So, E 2 this rotation while we are giving the E 1 double prime. So, here this will be E 2 double prime, and this line will also rotate. E 1 E 2 prime, then we have given this rotation. So, rotation will show it like this. So, first E 3 prime is along this direction itself, and E 3 double prime will be along this direction, as we have written earlier. This angle is theta here. It should be now clear, very much clear, that where these lines are lying. The last rotation then we are giving about this line by phi. So, phi dot will lie here in this place, okay. And this line then it will rotate. Now, this line will rotate and go to this position, it will come here. Okay. So, this is your E 2 triple prime, and this will also rotate, and say this comes here to this point E 1 triple prime. So, this angle is your angle phi, this angle is your phi. So, you can see that in which plane they are lying. Okay. Now, as we can see that we are interested in finding omega 1, omega 2, omega 3. This is my interest. Okay. So, as we can see that phi dot is already along the omega 3 direction. So, here is your E 3 prime, here E 3 prime triple prime is lying along the same direction. So, now we tag it as E 1, this as E 2 and this as E 3. Instead of using the E triple prime, we are writing as E 1, E 2, E 3, which is the final orientation of the body axis with respect to the inertial axis. So, the phi dot is along the z direction. So, it is directly contributing to the omega 3. So, I need not rotate it, there is no once you see in this frame the E 1, E 2, E 3 frame. So, already the phi dot is lying along the z direction and therefore, there is no need to convert it. Okay. Next, we take up this theta dot, your theta dot is here, okay. This is theta dot. So, theta dot is here, psi dot is here. So, this theta dot we need to convert. So, now look into this frame, how many rotations we need to give to finally reach to the body axis, which is a small e 1, a small e 2 and a small e 3 frame. So, if we give just one rotation, okay, so we are reaching to the body frame, and why we cannot add these three theta dot, psi dot and phi dot directly, because these are not orthogonal to each other. Psi dot, theta dot and phi dot, they are not orthogonal to each other. Had they been they say if they were perpendicular to each other, it would have been direct, like what we have done earlier. We could have directly written as R 3 and here psi dot, theta dot, phi dot, and we would have got the final omega 1, omega 2, omega 3. But here in this case, this is not valid, because these are not perpendicular to each other, and this rotation rule R 1, R 3, R 1, R 3 you are applying this rotation, this pertains to the orthogonal rotation. Means, if the components you are taking or whatever the vector you are taking which you are trying to rotate, if they are perpendicular to each other, okay, making a triad perpendicular to each other, then only you can use this rotation and convert to the other one. Like here, if I give rotation, so I can use this. Okay, here I am giving rotation by psi here. Okay. So, you can use this rotation R 3, because here all the three axes are perpendicular to each other, but here in this case theta dot, phi dot and the psi dot, they are not perpendicular to each other. So, never do this mistake of adding them together with this rotation, it will be a totally wrong thing to do so. Okay. So, the next rotation, this theta dot can be converted to the this E 1, E 2 and E 3 by just by one rotation, because here if you look that this theta dot, we will take this here as E 1 double prime, E 2 double prime, okay, and E 3 double prime. This is my axis. From there I have to go to E 1 triple prime, E 2 triple prime and E 3 triple prime. So, that can be done just by one rotation about the z axis. So, if I do this, so means I have to give rotation about the z axis by phi. So, this will be cos phi, sin phi, minus sin phi, cos phi, and this is operating on theta dot. So, theta dot is along the x axis here. So, here in this case, so we put here theta dot, rest others are 0, there is along this direction there is nothing. Okay. Along the E 2 E 3 double direction, along this direction, this is already phi dot we have taken care of. So, there is nothing to do with that. So, theta dot is one component which we are trying to finally convert to the E 3 triple prime, E 1 triple prime and E 2 triple prime, E 3 triple prime and E 1 triple prime. So, the last one then remains is psi dot. So, psi dot is again along the z axis. Here you see here it is along the z axis, and how many rotations we need to give, that finally we convert it into E 1 triple prime, E 2 E 1 triple prime, E 2 triple prime, E 3 triple prime. So, we need to give two rotations. How? Already if you look here, this psi dot E 1 prime is here, E 3 prime is here in this place, this is your E 3 prime, here is your E1 prime and E2 prime is here. So, these are perpendicular to each other. Okay. So, in this axis system E1 double prime, E1 prime, E2 prime and E3 prime, in this system this is forming a triad, a rectangular triad, they are perpendicular to each other. Okay. Therefore, if I rotate it by theta first, so this is my first rotation that I am giving, and that rotation I am giving about the x axis. So, here I need to write it like this, and this rotation is by theta. So, this is cos theta, sin theta minus sin theta, and this is cos theta. Okay. The next rotation, then once we have rotated like this, so it has got converted to E1 double prime, E2 double prime and E3 double prime. The last one rotation is to be given to bring it to E1 triple prime, E2 triple prime, E3 triple prime, just rotate it by phi, and that rotation is about the z axis. So, we do it by writing like this. Okay. So, this is cos phi, sin phi minus sin phi and cos phi. Now, add all of them. Okay. Here this is 0, 0. Okay. So, first solve the matrix and then write omega 1, omega 2, omega 3 separately and put it back in the form of matrix notation, because here psi dot is also there and phi dot is also there. So, we cannot put both of them along the z direction. So, it is better to do it in a way like we can write it as psi dot, theta dot and phi dot. Okay. And in no way this is indicating that this is the x direction and this is also the x direction and this is the y direction or anything. These are the three vectors on which three components of the angular velocity vector psi dot, theta dot and phi dot, which if you operate by certain matrix, it will get converted into omega 1, omega 2, omega 3. And that particular term we can write as S theta, S phi, 0, C phi. For this you need to just add it up, first solve this and put it in a simple format, linear equation format. Okay. This will be basically in the algebraic format, I mean in the algebraic format, where psi dot, theta dot, phi dot will appear and this will act as those coefficients. So, this is S theta is nothing but sin theta and similarly this is cos phi. This notation we are following here to make it shortcut. This is S theta, C phi 0 minus S phi, C theta 1, 1 is here in this place, this is the second column and 0. So, this gives you omega 1, omega 2, omega 3 and 1 I will verify here in this place. Let us say that omega 1 I want to verify. So, omega 1 will be from this place I am writing here, there is no component along the omega 1 direction, this part theta dot plus cos phi. So, theta dot C phi, sin theta is 0. So, this is 0, this is 0. So, nothing contributes here. Now, we have to come to this place. So, this is little complicated, we have to first do this and then operate by this. So, first we need to work it out and this part I will write here in short. Okay. This is 1 here 0 0 0. So, this vector will get resultant into 0. From here this is 0 0 psi dot S theta, okay. And from here this is 0 0 and this is psi dot C theta, and this has to be operated by this. Okay. So, once we operate it, so cos phi this will be 0 and the other term will be sin phi times psi dot plus psi dot S theta times S phi, and the third term will be 0 because this is 0 here. Okay. So, what we get here, the first term you can check from this place whether it is a matching or not. So, if you multiply here this row with this column, what we see that this is S theta S phi times psi dot, will write in the here. This is your psi dot, and then plus this term will be 0, and this is C phi dot times C phi. So, check here, is it same, this is psi dot, here we have written it the wrong way, this is psi dot phi dot, phi dot, and here this is theta dot. So, going into this S theta S phi psi dot, this part is 0, and this is C phi theta dot, phi dot times C phi. So, here we need to correct this also, this becomes theta dot times C phi, theta dot times C phi. So, same way you can expand it and write this kind of terms, and once you put this kind of terms in this matrix notation. So, it will get converted into this. So, on the right hand side we will have psi dot, phi dot, this is okay, and this is theta dot, and these terms are also okay, theta dots here these terms are together. So, S theta and S theta times C phi, these two are together, okay, these two are together. This is the second column, this is the third column, this is the first column. Similarly, the first row, second row, third row. So, this way omega 1, omega 2, omega 3 we can get from psi dot, phi dot and theta dot. So, you are basically getting here 3 linear equations, okay, in terms of theta dot, psi dot and phi dot. Then only you will be able to represent it. If it is non-linear equation in psi dot, phi dot and theta dot, so it's a matrix representation will not be possible in terms of theta dot, psi dot, phi dot. So, for your omega 2, it can be, if you check from this place, it will appear as theta dot sin phi plus psi dot cos phi times sin theta, and omega 3 as psi dot cos theta plus phi dot. Okay. So, this you can solve for theta dot, psi dot and phi dot in terms of omega 1, omega 2, omega 3 and vice versa. So, already we have this relation, and if we invert this matrix we get psi dot, phi dot and theta dot, okay, or either you can solve this linear equation directly and get here psi dot, phi dot and theta dot. If you want to change this, let us say that rather than writing here in this format, you want to write it as omega 1, omega 2, omega 3. We want to write in terms of, here instead of writing psi dot is okay, here we want to change it, make it theta dot, and this part we went to make phi dot here in this place. Then the changes you need to do that these two rows will get exchanged. Okay. That means that here you will have C theta 1 and 0 here in this place, and S theta C phi, S theta C phi will come downwards, this will be 0 and minus S phi will be here in this place. Similarly, this term, because psi dot is in its original position. So, we do not have to change it, this is S theta S phi 0 and C phi, that remains as it is. S theta C phi and it is okay. So, this way you can do the conversion. Now, we need to get psi dot, theta dot, phi dot. So, mark this change that I have interchanged this position of theta dot and the phi dot. So, if you interchange it, the rows are also interchanged. and if we want to write here the psi dot and phi dot theta dot. Okay. So, by doing the matrix inversion or by solving the linear equation, which I am skipping because it will take time, this you can do as an homework. So, you can see that if theta equal to 0, you get the singularity problem. Okay, as I was telling you earlier that if this angle is small, so this blows up, okay, and you will have trouble working with this matrix notation. However, you will not have trouble if you work with this linear equation and theta is equal to 0. So, you will not face that particular trouble. Okay. So, while working with matrix notation, you have to be careful. This R 3, R 1, R 3 in this rotation, if this is pertaining to theta rotation, and if this happens to be 0, means we get the trouble here in this place. And therefore, this kind of, whenever you are thinking that in your particular system you are dealing with this angle, if you are trying to use this kind of rotation R 3, R 1, R 3. So, you should be careful that if R 1 happens to be a small rotation. So, you should avoid this, rather than using this you should use like the first rotation giving about the R 3, then the second R 2 and then R 1 like this. So, then you will not face this kind of trouble, but here again certain kind of other kind of trouble can be there. So, due course of time obviously, those things will appear. Right now we should not worry. Okay, so, this concludes our the rotations, and you can do all these things as a homework. It is necessary to do certain exercise, which I will put in the form of tutorial also. Next we go into the torque free rigid body dynamics, means already we have used the Euler's equation. So, we continue with the Euler's equation torque free, but here in this case the torque is not there. Torque free rigid body dynamics. So, Euler's equation we have written as I 1 times omega 1 dot minus omega 2 times omega 3 times I 2 minus I 3. We are writing in a circular way, as I have told you earlier. This will equal to the torque acting on the system, either we show it by T or M. Perhaps I have used the notation M. So, I will write here M is the moment, and this quantity will be 0. Okay. If it is torque free, means this is 0. So, this implies I 1 times omega 1 dot, this equal to omega 2 omega 3 times I 2 minus I 3. So, let us make this as equation 1. Similarly, you will have I 2 times omega 2 dot, if the torque is 0. So, only this term will appear there, and in the circular way we are writing omega 3 omega 1 I 3 minus I 1, okay, and M 2 equal to 0. So, this is your equation 2, and the last equation I 3 times omega 3 dot, this will be omega 1 times omega 2 I 2 minus I 1, omega 1 3 1 I 1 minus I 2, this is I 1 minus Oh, I1 minus I2. This is equation number 3. Now, this kind of torque free rotation you get in the case of the satellite. Okay. Not always, but in certain cases, as we will see that the gravity gradient will discuss later on the lecture. So, those are also present. If you are considering the case of a top or a gyroscope, like you are playing with a top. Okay. So, if you are playing with a top, it is not a torque free motion, the gravity torque is acting on that. So, here this particular one discusses the ideal case, which happens in the case of some of the satellites, where there is no external torque acting on the system, it so happens. Okay. So, what we assume that, let us assume that axis of symmetry is present. Because that simplifies the case, this case quite a lot, and it makes it easy to handle. Okay. If it is non-symmetric case, it will be complicated, you will not be able to get any picture from this. Okay. So, what we assume here, that I1 equal to I2, this will write as I, and I3 will write as I0, and therefore, our equation of motion, if we insert here in this place, this gets reduced to omega 1 dot, this equal to omega 2 omega 3 I2 minus I3. So, I minus I0 divided by I, this equation number 4, omega 2 dot, this from this equation, this will be omega 3 times omega 1 and I 0 minus I divided by I, this is equation number 5, and similarly omega 3 dot, that gets reduced to omega 1 omega 2, and I 1 and I 2 both are equal to each other. So, this vanishes. So, I minus I, so this equal to 0. So, omega 3 equal to 0. So, directly from this place what we get, that omega 3, this is a constant. That is, if we go on the previous page and look here, omega 3 equal to phi dot plus psi dot cos theta, phi dot plus psi dot cos theta. So, this quantity this is omega 3 this is omega 2. So, the angular velocity and along the third body axis, along this axis, or here you can see along this axis omega 3 we are writing in this is omega 3, this is along omega 2, and from this place we have omega 1. Okay. So, omega 1 is along this direction, omega 2 is along this direction, omega 3 is along this direction. So, omega 3 value does not change with time. This is what it says, that if you have the torque free case of the rigid body, omega 3 will remain constant, means there is a relationship between the phi psi dot, and this is related by this theta. As I have told you earlier, this theta, this is called the nutation angle, psi dot, it is called the precession angle, and this psi is called the precession angle, not dot, and phi, this is called the spin angle. In the case of the aircraft, the same thing is called as the elevation angle. This is for aircraft. This is precession angle. Instead of this precession angle, we write this as the azimuth, and this is spin. Instead of this phi, elevation azimuth and then elevation, and this we can call as the bank angle. In the case of aircraft, things are much complicated. Okay. There is difference in the bank angle, bank about the body axis, bank about the velocity axis. It is a different terms, and the whole thing gets quite complicated, and it is out of context here. So, we are not going to discuss that. Okay, so, with this what we get from here, omega 1 dot equal to omega 2 omega 3 I minus I 0 divided by I. If we differentiate this once, so we will have omega 1 double dot plus equal to omega 2 omega 3. Okay, omega 3 is a constant, remember. So, this will not be differentiated, only this term will be there. So, I minus I 0 divided by I, omega 1 dot I minus I 0 divided by I, omega 3 is a constant. So, it remains there, and this is omega 2 dot. So, omega 2 dot omega 3 is a constant, I minus I 0 divided by I minus I 0 divided by I. Okay. Now, in this equation, put omega 2 dot is present here. So, insert it from the equation number 5. Okay. So, omega 2 dot is omega 3 omega 1 omega 3 omega 1, and then I 0 minus I divided by I 0 minus I divided by I. From equation 5, differentiate equation 1, differentiate equation 4, and this we have inserted from equation 5. Okay, so, this gives me omega 1 double dot equal to I 0 minus I divided by I whole square with minus sign times omega 3 square times omega 1. So, this we can write as minus lambda square omega 1. So, if you look here in this format, this equal to 0. Okay, so, this is we will name this as equation number 7. This is a simple harmonic motion equation. Okay. This format is of simple harmonic motion equation motion. So, it says that omega 1 will vary as a times cos lambda t plus b times sin lambda t. Okay. Similarly, if you differentiate omega 2 dot, means if you differentiate equation 5 and insert omega 3 is constant. So, insert omega 1 from equation number 4 here in this, we will get the same type of equation. Okay. So, if we differentiate equation 5 and insert omega 1 dot from equation 4, then we get omega 2 double dot plus lambda square lambda 2 equal to 0. So, we get the same type of equation, and here also the lambda square it is the same thing as we have written here. Here lambda square, this is nothing but I 0 minus I, or simply say the lambda equal to I 0 minus I divided by I times omega 3. This is your lambda. So, this is also the equation of simple harmonic motion. So, it says that omega 1 and omega 2 they are harmonic in nature, okay. They are oscillatory, and also we see that omega 1 and omega 2 they are perpendicular to each other, because they are along the perpendicular direction, here omega 1 and omega 2. So, these are two are the perpendicular direction to each other. So, rather than stretching it, it is a very easy to write from this place. So, the solution of this can be written as, you can write omega 2 this equal to, they differ by the phase angle pi by 2. So, if we insert here pi by 2, so this gets reduced to b cos lambda t minus a sin lambda t. So, this is the solution. So, they are not independent, they are related by this relationship, because the phase difference is pi by 2. So, this is your equation number 11. So, we can define a vector omega t as omega 1 E 1 cap plus omega 2 E 2 cap, and then we can write here a cos lambda t plus b sin lambda t times E 1 cap plus b cos lambda t minus a sin E 2 cap. So, this is your omega t. What does mean by this omega t? If we go here in this figure, so omega t lies in the plane E 1 triple prime, okay, it lies in this E 1 triple prime and E 2 triple prime, and this is very useful in the case of the we are discussing the case of a rigid body which is symmetric. Okay, so, this case we can look from this place, say this is a cylinder. This is the axis of the cylinder. Okay. And we have here E 1 direction, then E 2 direction, and this is E 3 direction. So, what we can see from this place that okay, we will change the notation little bit. Instead of writing here this as the what we want to do, that say I have this water bottle. So, consider this as a cylinder. Okay. This is a water bottle, and we can consider this to be a cylinder. If this body is spinning about this axis, okay, and simultaneously rotating like this, it is spinning and rotating like this. Okay. So, if I consider this vertical to be the inertial frame z direction, and from there it is rotated by theta angle, okay, and then spinning like this about this axis and simultaneously about this z axis it is going like this, as it happens in the case of the top. If you have ever seen a top or a toy gyroscope, so you will see that this keeps rotating on this axis and also it does like this. So, this motion is precession motion, while this motion is called the nutation motion. This is the spinning motion, okay. And angle from this to this, from this vertical to this, it is called the nutation angle. From this position to this position, it is a nutation angle, okay. And if there is variation in the angle, okay, if it is varying like this, it is going up and down whatever. So, this is called the nutation motion. So, precession motion is this, okay. This is the spinning motion, while this one is the nutation motion. So, here in this case it so happens that the nutation angle which we have written as the theta, it remains constant, okay. As we will see that this angle will turn out to be constant, and based on that then we will do certain relations, we will get certain relationship between psi and phi dot, because here we, as we see that if it is rotating spinning about this axis and also it is a precessing. So, what will be the relationship in the torque free case, not in the case of the top. Here you are discussing the case of the top. So, in that case if the C g is lying here, so it will get affected by the gravity, okay. But in the case of a rigid body which is free from the external torque, it will not get affected by the external moment. This is what it means. It is a free from the external torque, means there is no external moment, and then we are looking into the how the this rigid body behaves. And as a problem later on I will take the case of a top or you can consider that to be a gyroscope where the external torque is present. So, in that case how the equation of motion it changes and what are the consequences. So, we will stop today here and we will continue here in the next lecture. Thank you.